So, hello everyone, welcome. I I really hope that you can understand English because I can't speak Korean. And I hope that everyone did understand that. So, it looks like we're good. I also have a very bad tendency of speaking fast. So, if I do start to speak too fast, just throw something at me or just go like this, which means slow down, not I want to fly. Okay, so I'm going to show you a little bit about Kotlin and how you can use it and the benefits it has. How many of you are using Kotlin right now? How many of you have heard of Kotlin? Okay, that's good because I like audiences that don't know what I'm going to show them, because that means I'm spreading it to more and more people. So Kotlin is a language that we started in JetBrains in 2010, and we did it because we needed a language that needed to be concise, expressive, toolable, interoperable, but overall pragmatic. We create developer tools, as you may know. How many of you have heard of JetBrains, by the way? Use IntelliJ IDEA or some other tool related? Okay. We needed a language that complied with these characteristics because the majority of the languages, the majority of the tools that we use right now are actually written in Java. And as you write Java, you might know that it's not the most concise and expressive language in the world. At the time, there were two main candidates. One of them was Scala, the other one was Ceylon. We discarded them for different reasons that I don't need to get into right now. And that's when we decided to create our own language. It was developed from day one as an Apache 2 OSS license, and it was from day one on GitHub. What is it? It's a static language that targets the JVM and JavaScript. And we're also working on native. Okay, so hopefully at some point we'll have native support. The current state of Kotlin is that it was released in 2016 in February. So that doesn't mean that we haven't been using it beforehand. We've actually had Kotlin code in production for over 4 years, and other companies have had so as well. And it runs some of the core services at JetBrains. We have over 20 developers at JetBrains working on Kotlin right now. We have over 100 committers that are also obviously not all part of JetBrains, and we're using it in over 10 products currently at JetBrains. Any new product that we create, most likely it is going to be in Kotlin. External companies include Expedia, NBC News, Digital, Netflix, Amex, amongst others. Okay. So there are people already using Kotlin in production. Where can you use it? Anywhere. It wasn't made as a language to be used in Android development. However, given that it was compatible with Java 6 and still is, and it has a small runtime, it has gained a lot of adoption in Android. So a lot of people are using it on the Android. But we don't make mobile applications. We make developer tools, and we created it as an industrial language to be used for anything. Given that it's very similar to Java, C#, JavaScript, and Groovy, it allows a very quick ramp-up time. So I can promise you that anything that you see today, you'll understand. And it will be very easy for you to get up to speed with Kotlin. And also, given that it's very interoperable with Java, it allows gradual adoption. For us, that was a key thing, because we're a company that makes developer tools. We sell developer tools. Right now, we're over 600 people. We couldn't suddenly close shop and say, let's spend 5 years rewriting everything in JavaScript or some other language. We needed something that we could gradually migrate to, but we could use our existing code base of over 10 years when this started. So we focused a lot on the interoperability. How can you use it? You can use the command line. You can use Maven, Gradle, Cobalt, which is a flavor of Kotlin written in Kotlin. Although Gradle now also, how many of you are familiar with Gradle? So Gradle, you normally use Groovy. Now you can also use Kotlin for your Gradle scripts. And if anybody still uses that. IntelliJ IDEA, Android Studio, Eclipse. We make a plugin for Eclipse as well. We also make a plugin for NetBeans. And you can use it in IntelliJ IDEA Community Edition, which is the open source one. In essence, what I'm pointing out with this is that we're not locking you into anything. You can use it from anywhere. Command line is as simple as running a single command to compile the output. So with that, now let's just get rid of the slides, and I'm going to focus on some code and show you code. So create a new project. Normally when I'm writing code for like production projects, I use Gradle. For here, I'll just show you how simple it is to use Kotlin, because that way we don't have to pull down the entire internet as we do with Gradle. And we'll say conference Seoul. Now Kotlin comes with a small runtime that's under 1 megabit, and that gets included. I'm now going to create a file called a Kotlin file, and I'll call it main. I could call it anything I want. And I'm going to write main, and that expands a template for me. Okay? And I'll write print line hello and run. So I've compiled the output and I've run. Okay? And of course I can do things like, have a breakpoint as well. So let's extract this into a variable, and then we can set a breakpoint, and let's debug this. And you get all the goodness of the variables, everything you come to expect from an IDE. Okay? And of course you can get refactoring as well. So it very much already supports tooling, because that's one of the goals of the language. Now notice a couple of things here. This is the entry point for an application, for a console application. If it matches this signature, main args array string, notice that there is no class. So I don't need to have a static class and then inside that static class have a series of public static void main functions. I can just put a function anywhere in a file, right? So I can say fun hello and then print line hello, and that function belongs in that file. And I can write hello to invoke that function. Okay? Now, by default, you can name, the package system is the same as with Java. So you can say, org.hadihariri.sample, for instance. And of course, it will complain that that's not inside that package. So I'll just move it now to that package. You can have the packages aligned with the folders, just like you do in Java, but it is not a requirement in Kotlin. Therefore, you don't have to have death by 1,000 folders. But normally, we follow that convention. If you don't provide a package, it goes to what's called the default package. Okay? Now, what else can we do with Kotlin? So let me create a class, because Kotlin is an object-oriented language with some functional constructs. So let's create a class called customer. And this is a customer class. That's as small as it gets. You don't need the curly braces. You don't need anything like that. But now what I want to do is I'm going to create a customer class that has two properties, an ID and a name. Okay? So I'll write val ID int val name string. Notice a couple of things. We'll call this var. First of all, val means an immutable. It means read-only, right? So that means that I can't change the value. Var means mutable. So in essence, I've created now a class with two properties, one with a getter and a setter, and another one only with a getter. But in addition, this syntax, what it says is the constructor of that class needs to pass in two values, right? So if I want to create an instance of that class, I say val customer equals customer. Notice that there's no new word. 1, Hadi. Okay? And if I want to print line that customer, I can do so. And if I run this, see that I get a horrible little pointer here. Now let's make that prettier. That looks nicer, right? What I did was add data. But I did a little bit more than just add data. In fact, let me show you what I did using Java. So let's create a Java class. No, not JavaScript. Wouldn't be called dead writing JavaScript. Customer in Java. And here I'll do my little private int ID, private string name, And now I'll get IntelliJ to create the getters and setters for me. Well, I don't actually need a setter for this one, right? Let's be honest. But now let me go ahead and also do an override methods, and I need a hash code equals clone to string, right? Okay. Now let's go over here and show customer. Bring this down, bring this up. That is this. Okay, so, okay, you say big deal. You know, IntelliJ generated that for you. Yes, it did. But you don't know if that code is what you generated by default or if it's got some other modifications. You also don't get to keep that code the way it is when you add a property or remove a property. You have to update that. So you got a whole bunch of boilerplate code that you're writing for absolutely nothing. Okay? Why have that? Now that we've got that, let me actually show you some of the things in terms of interoperability. So I can come here and say val customer Java equals customer in Java. It doesn't have any constructor. In fact, there's more code because I didn't even create the constructor, and I should have created the constructor as well. Now customer in Java, I say get ID. But as soon as I hit get ID, it says no, you should use a property accessor. Because I'm in Kotlin accessing Java, therefore I need to write code in an idiomatic way in Kotlin, right? Kotlin doesn't have fields, it only has properties. Kotlin classes only have properties. So if I want to set a customer name, I say instead of set name, I mean I could of course say set name. By the way, notice no semicolon either. Semicolons are optional. That means you can now argue, just like you do with JavaScript, whether or not you should use semicolons. But it says use property access instead. Now if I come to Java and I use Kotlin, I want to do customer equals new customer, and that'll be one and something. Oh, semicolon. Customer get name. There is no name. There is just get name because I'm in Java. So I expect to work with it as in Java. Okay? So what else do we try and do? We've seen how we can cut down concise, create code that's concise. Well, to begin with, we can have obviously functions with parameters. So I can have hello, or let's say message, and then say value, string, print line, value. I have string interpolation, so I can say message is value. Okay? Notice that I'm following the conventions of the variable parameter name and then the parameter type. By default, Kotlin returns void, which is called unit in Kotlin. And it's unit, and unit is actually an object. Object is basically a singleton. You can have an instance, a single instance of something, and you create it as an object. This is how you create a singleton in Kotlin. Okay? So I don't need to write this. I can have functions that are single expression lines. So this I could write like this, return x plus y. Okay? But given that this is just a single line, and given that Kotlin is very big in type inference, we can write this in a simpler way. Notice here I'm not declaring the type. Given that I'm initializing it to a string, it knows it's of type string. The full declaration of this would be string equals. Right? But you don't need to be explicit about types in Kotlin when the compiler can infer it. And the same case here, if my function only returns an expression, a single expression, all I need to do is just write that expression. cut down, again, a lot of boilerplate code. Cut down noise in this case. Okay? I can have optional parameters. So I can do z int equals 0. And if I don't pass a value, that will default to 0. So now I could do add 1, 2, add 1, 2, 3. I can have multiple default parameters. So what we're doing here is imagine that this in Java would be overrides, right? Here, sorry, overloads. Here, I don't need those overloads. Now, the problem is that what happens when I have multiple default parameters? How do I know if, if I'm passing two values, how do I know if 3 is y or 3 is z? In this case, it doesn't matter, but imagine if it did. Well, I can name parameters. Or I can do x equals 1 and z equals 3 and change the order. Okay? In fact, we added something in IntelliJ for Java. Given that you don't have that, you saw it here. Do you see this? It allows you to, it shows you the parameter names in languages that don't allow name parameters. Obviously, you can't change the parameter order there. Okay? Now, let's go back to our class here, customer class. Now, every customer is a person. So I could do person, and then come here and say that this is a person. And it will say no. Why? Because by default in Kotlin, classes are final. If I want to inherit, I have to explicitly mark them as open. Okay? Sometimes I want to actually add some functionality to a class, and I don't want to inherit from it. No, and it's not about this being open or closed. It's like, I just want to add a method to a class. Why do I have to inherit and create an absolutely new class? You don't have to. Let's go over here. I'll create a new file, and I'll call this file extension functions. Let's create a function called string hello. This is complaining because I already have a function called string. My hello. Okay? It's complaining because I don't have something written. Print line, hello, it's me. Okay? Val, some string equals something, some string, my hello. I've just extended the string class. I've extended the string type with a new function called myHello. Okay, let's create another one. Fun string should equal value string, and that's going to be this equals value. What's this? Given that this is an extension function on a class, right, of a class, it's the instance that I'm referring to. So I can now write this should equal this. That's nice. But I would rather write should equal this. That's nicer. I can't. Yes, I can. I create the extension function with an infix modifier, and now I can call it in infix mode. Okay? Now, any function or any member function or any extension function with a single parameter can be called in infix mode. Okay? Now let's go back to our customer class. Let's create a function that says my or evaluate, or let's say vacation days, and we'll say, no, let's call it evaluate. And then we'll say that this takes a person, and we say if person is customer, then print line customer, person name. Notice what's missing there? A cast, right? Because Kotlin has done a smart cast. That's why this goes green. And it said, I smart cast this to customer. It's not a big deal. But again, it's cutting down on boilerplate code. It's cutting down on noise. It's saying if the compiler can guarantee that this is a person, because you've just checked that this is a person, why am I going to make you cast it to a person? Okay. Let's go back to extension functions. How many of you know what a big decimal is? I'll tell you, it's a decimal that is big. Big decimal equals big decimal 1. That 1 now becomes a big decimal. And now I can operate on that big decimal. Divide, whatever. Okay? It's okay. But noise. Right? In Kotlin, I can represent a long like this. Value my long equals 100 long. I like that. I want something similar. But the Kotlin language doesn't have support for big decimal. Let me create it. I want to do something like val my big decimal equals 1 BD. How can I do that? I can create an extension property on integer that returns a big decimal, and in the implementation all I do is return big decimal of this. That's called an extension property. And just like you can create extension functions, you can create extension properties, and you can make your code more expressive. Okay? Now, in Kotlin, by default, you don't have nulls. So that means that if I have my string equals ABC, let's make this mutable, and I do my string equals null, it will say you cannot. Null cannot be a value of a non-null type string. You just got rid of the billion-dollar mistake, which is you cannot have nullable types. By default, you can't have nullable types. I can make things nullable. I add a question mark to it. Now this can be null. So then I can write my string. If my string is not null, then print line not null. Okay? This is again painful. I can do it in an easier way. Or let's not even do print line not null. Let's do something like, I don't know, get the my string length. Okay? And then do a print line on that, for instance. Right? Instead of writing that, I could just do my string length print line. Okay? So this is called the Elvis operator. And what it does is say, if something is not null, then do something with it. Cutting down on all this noise. Why do we have nulls? Well, because sometimes you need nulls. And effectively, if we wanted to interoperate smoothly with Java, we have to accept nulls. Because anything you call in Java can potentially be null. So when you interoperate with Java with Kotlin, we give you the option of saying, is the return value going to be null or not? And if it is, you can then operate as null. If it's not, then you don't. When you do need to operate as null, then you can just use the question mark here. Is the Elvis operator. Okay? Now this thing that we saw in extension functions, this is nice, should equal. What else could I do? So how many of you are familiar with higher order functions? Higher order functions is a function that takes another function. Okay? And in Kotlin we have higher order functions. So in essence, it's a functional language because it allows you to treat functions as first-class citizens. So let's go ahead and create a new file, higher order. And let's work with lambdas and all of these things. So I'll create a function called higher order that takes an integer, another integer, and then takes a function that takes an integer, returns an integer. And this in turn is going to return an integer, which is going to be applying x, y to the actual function. So I have a function which is higher order because it's taking another function. That function has two parameters, integer of type integer, returning integer. And what I'm doing is effectively just invoking that function. So how can I actually use this? I could do something like higher order 1, 2, and then pass in any function that matches this argument. I already have one. It's called add. Right? Well, no, I don't, because add's got 3. Okay? Now I do. Now you don't have to explicitly create a function and then invoke it, pass it in using colon, colon on the name. You can pass in what's called a lambda expression. So I could do 1, 2, x, y equals x plus y. Very concise. This is a lambda expression. Okay? Now in Kotlin, we have this convention in which if you pass in as last parameter to a function a lambda or another function, you don't have to put it inside the brackets. So I could do x plus y, x plus y. Okay? And I could even do multi-line. So, how many of you are familiar with C#? C#, we have this thing called a using statement, which is kind of equivalent to like try with resources. So I say fun using. Well, I don't have using in Kotlin. Let me create it. Using object closable. Block of code. What I want to happen is that I invoke that block of code and I want to make sure that the object that is closable is always closed. Right? So now I could do using my closable, whatever that may be. Let's just go ahead and create that for now so that whatever. Imagine that that doesn't give an error. Using my closable, and now operate with that. So I've just added a small function that allows me to operate with that smoothly and making sure that every time someone invokes that, it is going to call close. Okay? What else? We've got a bunch of functions in the standard library that provide these things. I mean, I can say, let's create a numbers 1 to 100, right? And now numbers filter those that are less than 30. Right? What that is doing, what is it? If a lambda, if a function takes a single parameter, I don't need to explicitly declare that parameter. I can just refer to it as it. And once I get that, let's map to the it times 30. And then on that, let's do a for each and print line the result. Right? And you can now put these on a separate line. Okay? So all of these come as part of the standard library. And you can see that basically they're extension functions on different generic types, iterables, etc. You also have lazy evaluation, which in Kotlin is called a sequence. And you have other things, like for instance, with file, some file.txt. That's a Java type, right? Do something. What does this with give me? Well, what does a file name have? Let's take a look at file. It has a path name. Path. I'm accessing the properties of the file without having to constantly put the variable name, the instance. What is with? With is a function that comes in the standard library which says calls the specified function block with the given receiver as its receiver and returns its result. So effectively it allows me to cut down noise by just referencing the properties of that object without having to continuously prefix it with the name of the object. Okay? And those are just some of the things. Like there's a whole bunch of different things that you can do with Kotlin. We also have like lambdas with receivers that allow you to create DSLs in that. And I can show you some of these here in the slides. So Anko, for instance, this is a statically typed DSL for creating Android views as opposed to using XML. All of these are static links. They're either functions, they're properties, etc. Android extensions, if you do any Android development, is a plugin that allows me to refer to elements on the view in a static way and not have to do a find view by a string and then cast it to a specific type. Spring Boot already has support for Kotlin. If you go to Spring Boot, you can select Kotlin as the language and away you go. We've got a lot of good fans and proponents of Kotlin at Pivotal. Cobalt, as I mentioned, is a flavor of Gradle using Kotlin. And then, of course, there is Gradle itself. Spec is a framework I wrote, which is for for testing. You know, if you're familiar with Mocha or Jasmine from JavaScript, it's the same kind of thing. Gradle, as I mentioned, now supports Kotlin. You can already write your Gradle scripts in Kotlin. That's what I've shown you, some of the stuff in 1.0. We're already working on 1.1, and we're going to have a whole bunch of new things like coroutines. Coroutines will allow asynchronous programming. But given the way Kotlin is designed, we're not going to do asynchronous programming in a specific way. We're not going to force you to do async await keywords. We're going to provide this functionality as part of the standard library, and then you can choose how you want to do asynchronous programming. So if you want to learn more, go to kotlinlang.org. If you do go to try.kotlinlang.org, you'll get kind of like an in-browser IDE, so to speak, where you can do a series of koans. If you prefer, you can also take those koans offline and just open them up. They're on GitHub, so you can get to them from the website. There's already a bunch of books out. 2 of them are Kotlin for Android developers and Kotlin in Action, which is by my colleagues. I've just delivered an O'Reilly course, so if you have access to Safari online, that's not accurate. It's about 8 hours, not 9.5. But it's 8 hours of diving into every aspect of Kotlin. We've got a very active community channel on Slack. There's over 5,000 users currently, I believe, or close to 5,000, and very helpful, very active, very engaging. And to summarize, the idea behind the Kotlin isn't a major a shift from what you know. This isn't going from a paradigm shift of I'm doing, you know, C Sharp or Java and now moving to Haskell. It has functional constructs, but it's about leveraging the knowledge you have, writing more expressive and concise code. I can tell you that by average, our stats show that your code base could be reduced by around 40%, right, and still be readable. It's got a very easy learning curve. Given the interoperability, it provides you very low risk adoption. And obviously this is a very subjective thing, but I find it very enjoyable. And I'm sure that you will too. Who writes Kotlin code? Do you find it enjoyable? Yeah. Yes, there you go. You see, you made me look good. Thank you. I'll give you the stickers later. Shh. Okay, and Kotlin is here to stay. We didn't create Kotlin to then create a business model of consulting or training around it. We created Kotlin because we needed it for ourselves, and obviously we hope that if you do use Kotlin and you combine that with other things, then ultimately you'll be buying IntelliJ IDEA. But again, it's also available in all features in the community open source edition. And Kotlin itself is open source, and as I said, we offer Eclipse and NetBeans. And I'll finish off with this tweet which says, researched Kotlin last night and then spending the morning looking at mountains of boilerplate Java in Android Studio. I see why they did it. And that's precisely why we did it. Thank you.